A Nephilim spider joining the monsoon banquet. She's caught a tiger butterfly. And he is utterly toxic. Butterfly predators need to learn this. A Nephilim spider joining the monsoon banquet. She's caught a tiger butterfly. And he is utterly toxic. Butterfly predators need to learn this.
System error. Shutting down.
Walk, don't run. Use the handrails. Walk, don't run. Use the handrails.
Neon Temple simulation reboot in progress. Live stream initiated. Stabilizing environment.
Back. We hope everybody enjoyed their Thanksgiving. That was a good Thanksgiving for me, mainly because I spent it with Dr. Sunny, and actually I think I had 2 weekends in a row spent with Dr. Sunny, because we had her birthday thing, and then she spent Thanksgiving with me and Laura at the in-laws' house. And one can only hope that Dr. Sunny's skills can rub off on we lowly peasants, and remember, you too could choose to not suck at web apps. So we are at the end of the year. It's been one hell of a year, and we have this session, next week's session, which is going to be something Trey booked. It's Rogers, right? Yeah. Mike Rogers, the Grand Poobah of B-Sides Tampa, is going to be talking here, and then after that, we are going to have our last session of the year, and we are currently game planning out what that is. Stay tuned. If we keep having the draw out that we keep having, it's just going to be me berating you all, because fucking do better. You guys pay money to be here. Yeah, so with that, we're kind of heavily leaning towards no range day this year. I don't have the time to do it. Trey doesn't have the time to do it. So yeah, that's that. So we're probably heavily leaning towards no range day this year. If you all want to put on a range day, that is within your power. And if somebody wants to come to the temple with numbers of how much something costs, we could talk about funding it or half funding it. But we are not doing the legwork for that this year. I'm burnt the fuck out. He's burnt the fuck out, and that's just how it's gonna go. With that, also we are taking talks for January of next year. I've got a couple lined up. Me and Trey want to hit Q1 really, really, really hard. So if you have a talk, if you have somebody who wants to give a talk, we will be taking papers for that. And with that, speaking of papers, so the way this speaker came about, without going too much down the rabbit hole this year, so the one B-sides that's in Tampa Bay, and if there is another B-sides, I've never heard of it, was a little light this year, I would say, around the content, and a whole bunch of people that I know that are worth a damn submitted CFPs, and for some reason that at least I don't understand, probably something that has to rhyme with sponsorship, those papers were rejected. And this is such one of those talks, and here at the temple, we love people with skills that pay the bills, and we love good talks. So, RJ, who is back there dressed like a school shooter going to a country bar, decided that he wanted to link us up with this speaker so she could give her talk to you all at the temple. And that's what we did. It took a couple months to get it done, but yeah, we are excited. Tonight's talk is going to be actually, at least in my humble opinion, one that I've been really excited for. We've been working on this one since B-Sides Tampa. And with that, we will introduce the speaker tonight, Dr. Jennifer Olds. Jennifer, take it away.
Thank you guys. Yeah, so this was a work in progress. I was going through my doctorate at the time, and once you're getting ready to defend, I got to tell you, it takes a lot out of you. So I passed, thank goodness. Thank you. And here we are. This was one thing that was high on my list to do because I don't hear much about this topic. And what we're going to be talking about is, let me get this going here. There we go. The firewall saga and other issues in medical device cybersecurity. Maybe things that you are aware of in the verticals that you work in, maybe not. But what I would like to say is I welcome questions as I'm speaking. So please feel free to just speak up, raise your hand. I'm happy to answer questions. So with that, I'll go ahead and start. So good evening, everyone. It's great to be here. And I want to thank you for giving me this time to speak on my topic. Again, if you have any questions, feel free to speak up. I'm happy to stop and answer them. I'm Dr. Jennifer Olds, and my work sits at the intersection of cybersecurity, healthcare, and manufacturing, with a strong focus on protecting medical devices and the patients who rely on them. Before we get into tonight's topic, I want to share a little bit about me. I come from a long line of engineers, teachers, and farmers. And in my immediate family, I am a first-generation college graduate. I'm a lifelong learner. I like listening, asking questions, and sharing what I pick up along the way with those people around me. Outside of security, I enjoy gardening and saving plants from the clearance rack at the big box stores. I'm notorious for that. If they're dying, I must take them. I'm also a novice photographer, and we'll be sharing some of my work tonight, one of which is up on the screen. About this photo, I was living in LA at the time, and I was walking through the Hollywood Forever Cemetery, and that's behind Paramount Studios. And I know that may sound weird. Why are you going and walking through cemeteries? Well, it was the time of COVID, and you literally weren't allowed out on the street. So where else does one go to get some steps in? You go to the cemetery because you're really not going to catch anything there. I mean, that time has passed. And with this photo that I took, you know, I walked up on this tree and I'm like, wow, this is such a beautiful tree. It's really cool. But then I took another perspective. I came up closer to it and I started taking pictures and I noticed it was full of bees. And those bees, they were sleeping. So then I realized this really was really and truly a place to rest. So not only were there people there, there were bees there. So our agenda tonight, I'm going to talk about some common ports found open on medical equipment, some cybersecurity issues, and some of you may know some of those issues I've talked about before. We're going to talk about software firewalls, hardware firewalls, and then I'm going to look at a couple of pages in my research. You may find them interesting. So throughout this PowerPoint presentation, I decided to pull in some of the slides that were impactful to my defense, and this one was. And I got to tell you, the more I look at this photo, I'm like, this may be AI. But I did purchase this photo, and it jived with my research. So I used it, because this is what I was going to use. Yeah, that just, no. I was afraid if my committee saw that, they'd be like, no, Jen, this is just no. So to make this experience genuine, I've included images that I've taken on my journey. So you get an idea of what I'm talking about and what the equipment or the medical devices actually look like in those situations. So here we have on the left an anesthesia machine. So if you're wheeled into the OR, that's where the anesthetist is going to sit. This is a ventilator, a patient monitoring system. This is where the gas is at. There's suction on here. And then on the right, we have the drug carts. And for reference, the OR is where, in this photo, this guy sitting right here, sitting down, that would be the anesthesiologist. So that's where he would be sitting, is in this area. So throughout my presentation, you may hear me talk about a few different communication protocols. And I'm just going to highlight the high-risk ones that we have on here. Port 21, which is the file transfer protocol. 22, which is SSH. 23, which is Telnet. 80, which is HTTP. 3389, which is RDP. 445, which is SMB. And then 1883, which is MQTT. So despite what you may have heard, medical devices are not capable of accommodating all NIST controls. For instance, with endpoint protection, resources are taken away from legacy equipment. They come very bare bones as it is. So if you decide to add something to it, it's going to shut it down. Concerns here are, what if a scan kicks off while the device is in use? So there's a patient on it. And what if the device needs to reboot after that scan? We've all seen that. In fact, that may have happened to me before you guys came in. We had updates. And this has happened live in hospitals. Next is network scanning. And one device I'm going to talk about is called, I'm going to talk about it throughout this system, is called the Volcano system, which are used in cardiology departments worldwide. They were shutting down during procedures. It was found that the device was not compatible with the network scanning programs hospitals were using. And they weren't the only devices. When scanned, infusion pumps, which are drug pumps, they can stop working. And I've seen it happen many times. They just absolutely stop. Yes, absolutely. It's very common, and it's just something that we need to take very seriously, because it's hard on nurses when they're up in ICU or CCU and they have 20 of these pumps going per patient and all of them have to be restarted. Sometimes they can be restarted, sometimes they can't. You have to get another pump because it starts working against itself.
Like maliciously, Goss, or just?
I mean, it depends. Hang on.
Oh, just 20 pumps per patient?
Sometimes in critical care, depending on what is going on with that patient, and I have to say the last time I was in critical care was during COVID, and I was out of my mind shocked to see how many of those drug pumps were being used just to keep a patient alive.
So a lot of protect, like carbon black, for instance, or a lot of endpoint protection that's specifically meant for OT might slam it like both in and out with it, like gigs or even megabytes, like megabytes of data. And whenever you're dealing with a small kind of monofunctional device, it's not meant to handle that much data, so it essentially pisses its pants.
Yeah, so that's
Yeah.
It's not necessarily like malicious attack, it's just information overload.
Yeah.
So it pisses its pants. It happens a lot on airplanes too, allegedly.
Oh gosh. So when it comes to NAC, Network Access Control, I don't recommend NACing medical equipment because the time it takes to get that equipment out of NAC and usable, which may include rebooting that medical device, and you know, a hospital system could have 60,000 different medical devices. We don't know how all of them are going to react, so the best course is to just not put them in NAC. Using NAC has caused departments like imaging, oncology, EEG to kind of go on divert. And I know we're used to hearing an ER department going on divert, but when I say these systems are totally down, they've been NAC'd, and it's going to take, it could take an hour, 2 hours for it to come back up. So they have to send these patients elsewhere. Or it could even divert certain portions of the ER. If someone comes in, they need to have a CT immediately, or they have to have an EEG because they've had a stroke. It's just hard to tell, but it has happened. And while these are just a few examples, I want to take a moment to talk about USB ports. And I think we're all on the same level with USB ports and opened ones. Some manufacturers use USB ports to elevate privileges during maintenance. These are called USB dongles, what the medical device manufacturers use. Others use them to scan the system for viruses and worms, and I have to say, if I may mention a brand here, Trend Micro has a great brand that you can take a USB, plug it into the device, and it automatically starts scanning that system to see if there's viruses, worms, whatever that may be on the device. I highly recommend it. It works great. But because USB ports on many of these devices are in use, USB locks become important. They help reduce data leakage. So here's some things you may not know. So these locks keep employees from using the equipment as a cell phone charger, because if we see an open USB, we want to plug it in. Oh, I can charge my cell phone. And of course, that's a whole other risk. It stops juice jacking, because we do have employees who aren't so for the organization sometimes. Yes?
So I know on aerospace parts, whenever we have a JTAG port or USB port, a lot of times they'll blow the fuse on the port before they ship it, because they know nobody's ever going to plug back in here. Like if we need maintenance, they send it back to the facility. How often are USB ports actually used legitimately when they're deployed in the field?
So from what I have seen in every medical device that I have worked with, they are used for one reason or another. And in some cases, it's because the medical device is so old, but it does have a USB port on it, that the doctor has to take that information from the device and put it on his station within the hospital, because it's not allowed to be hooked up to the network anymore. And it could be something as simple as a Windows XP device. It's just too old to be connected. So that's how they do it. And it's like, okay, we just have to have a policy around that. That USB's got to be scanned before it touches that medical device, and it's got to be scanned again before it goes into that computer. And somebody has to have control of it. It can't leave the building. So it basically has to be signed out.
Follow-up question. So for employees, are there often acceptable use policies written into the employee contract of don't plug your stupid devices into our medical equipment? as far as charging cell phones, or are they not up to that yet?
So I don't think they're up to that yet. I think we're still kind of getting those basic foundational ones put together, but it is something that has to be taught. And here's something else. When you plug in a cell phone into a medical device, there is many times AI on the network. So everything that's on that cell phone, we see. Websites you've been to, images, your password for your bank, we see it all. Because this is something, the AI is very aggressive. It picks it up and it's just like, oh gosh, what have we found? We have to contact this person and tell them to change all their passwords because now we have them. So one other thing I wanted to mention with the USBs, and I'm not going to say if this happened or not, but this is a takeaway, an opportunity to download patient data, which could be sold to TMZ or lost in a parking lot, supposedly. That may be an issue at certain hospitals. Now we'll move on to some cyber issues that I've encountered. And this is one picture that I took. Can anybody guess what this might be? So this is an EKG, someone's EKG. What are those blue lines? Anybody? Okay, so the patient is alive. That's not, any type of shock or anything like that. What that blue line is it's very dangerous because it really does come up. That is a router failure. So with the stack of routers that are involved in transferring that data was dropping packets. It shows up on the EKG. So, and if a healthcare system does not know this and they experience this, they're like, oh my gosh, what's going on? They're going to have a nurse at the side of that patient immediately checking out, okay, what's going on with this? Let's get another EKG machine in here, check some things out. It took about 2 months to determine what the problem was. And I actually got on a call with the vendor and the manufacturer, and I said, what is this that we're seeing? They're like, it's absolutely not us. We're not seeing anything. And I had a network guy there, and I said, hey, can you ping that stack? Tell me what it's doing. He's like, oh, it's dying. And I'm like, that's what that is. So it's important to keep up with your routers as well, any type of network equipment. So that's what's called an MQTT signal disrupt. And that's those blue lines there.
So this EKG information is all this is just what's transmitted to the nurse's station.
Exactly. Yes. So instead of a nurse having to be right in that area, you're going to have a monitor tech, and she's going to have several screens up there, and that's what she's going to see. That's where we started seeing that. And here, with this patient, they could not be discharged until they were deemed healthy. And anytime a doctor or someone comes in and says, we have to keep you a little bit longer, what do? You're freaking out because you're like, whoa, I'm here for a cardiac issue. Is there something wrong with my heart? It was undue stress on the patient, and it cost the hospital quite a bit of money, and then it cost the insurance company quite a bit of money because it took time. So when we talk about another network issue that I have come across is a mix match of speed. And by that I mean the NIC on the back of the medical device may be sending at 10 gigs, right? The wire has also got to be 10 gigs, right? Sometimes it's not. So we have a bottleneck right there. Sometimes when we get to that good old router that's failing, we find out that's a 1 gig. So we're trying to figure out why it's taking 20 minutes for an image to get from this room to across the hall. It's because we have a mixed match in speeds. Everything needs to be 10 gig all the way out. And sometimes when that data gets backed up, we get what's called a bottleneck. And that bottleneck can sometimes crash that medical device.
These are all using QTT?
Mm-hmm. Yeah. Yes.
So does the manufacturer of the medical equipment put out required network specs for up down for data transfer between like a device and whatever the endpoint is?
So it depends. They're all not on the same page. However, when you have major medical equipment like MRIs or breast biopsy systems, the whole logics, you'll have a specialist that will come in there, a product manager or a program manager will be there, and they will say, okay, we need to make sure that from here to here, even out to the cloud storage, we're getting 10 gigs because we don't want any bottlenecks. We want this to flow smoothly. Sometimes that happens, sometimes it doesn't. So one of the biggest things on here, of course, we hear about all the time is the lack of updates. Because human lives matter, the manufacturing industry and several governing bodies are careful about what they allow to be added during an update. After all, an update can cause the device to behave unexpectedly, or it could open up new vulnerabilities. And we've seen that like with other software, third-party softwares out there. We've seen that. Misconfigurations from software are another issue. To how the device is connected to the healthcare network, to the ports being left open, there are so many misconfigurations that we're just missing. And I want to talk about insider threats. And when we talk about insider threats, they're mainly human errors. We all make them. I know I've personally shut down a network when I started out after interning. I've done it. But there are disgruntled employees, employees looking to harm others or to get access to certain medications, like drugs. And we're going to talk about that in a few moments. Longevity of that medical device. Medical devices are living longer. That sound weird? But they are. Windows XP is still out there. It's just still working. All it does is it counts drops in many cases. So if all it's doing is counting drops, it's going to last for a while. Okay. So this image has been altered to protect the organization. If you're not familiar with Shodan, you should be, because that's where this came from.
There was a big sale, and I told everybody here to get a freaking Shodan license.
Yes. If you're a student, you can get a free license. They'll hook you up. Yes. They're so well needed. And to protect your organization, I got to tell you, it's not just, it's going out there and finding different lenses, different perspectives of what it is you're looking for, because you may just type in your domain name and it doesn't show up. It could be just anything and it shows up. And with this one, I said, show me medical devices, what's coming up here? And this came up and I was like, oh my gosh sakes.
Yeah, it looks like somebody's got scoliosis.
Yes. So this medical device was found open to the internet. The device reported as a Konica Opal Rad server, imaging device, of course. The device is vulnerable to Blue Keep, and the showing port 3389 as being open. Additionally, there were newly published CVEs 2024 33606 and 28877 show that this model is vulnerable to a stack buffer overflow and unauthorized DICOM manipulation. Does anybody know what that is? Okay. Unauthorized DICOM manipulation. So they could manipulate that image. So if that was someone who, well, we have scoliosis, they could have straightened the spine. You don't have scoliosis anymore. Or if there was cancer there, they could have removed that and made it look like totally normal.
Just out of curiosity,
Yeah.
Why the hell does, okay, hang on, SBC kid, what's port 3389 think fast? Good for you. So why does a medical device need freaking RDP open on it? Like, even if it's not connected to the open internet at large, like why?
So a lot of them.
That's my question. Why is that open?
The easy answer, the short answer is a lot of them are going to like just
Oh, fuck yeah.
So that's how they're feeding all of these views to everyone, or even like to the tech watching all of the EKG machines. Those are
What?
feeding to a central point that they're just getting a thin client that accesses the view.
So they're hold on, just so I understand that, they're walking medical information.
Basically.
That is the shankest shit I've seen in the last 12 hours.
But
for medical equipment,
Next time you think about that, next time you go to the doc, like outside of the VA, go look at the actual systems they have hanging on the wall.
I was about to say.
They're not full endpoints. It's literally just a thin client to feed video to
Yeah, because the VA ain't got this shit. The
Yeah.
VA's still on Windows 95.
But yeah, that's basically what's happening. That's why RDPs open everywhere.
So for this one, I'm sure you've probably already read that this is a Pyxis med station. This is where they go and they get the medications out of it and they put it in your arm or in your mouth. That's what this is. This organization has also been redacted because I didn't want to put their business out there.
Fuck.
I got to tell you, I found some really bad ones, and I did reach out to the company, and they did not receive me well. And I said, look, I'm a researcher. This is just what I found.
You're trying to help them.
Yeah, the nature of being a bug bountier.
Yeah, so port 80, 443, 3389, there's a lot of, that's interesting. That's interesting. This one is probably one, this is not my image. This is one that was taken and found its way out to the internet, and this is a Bear MedRat MRI, and it got WannaCry ransomware on it. So I don't know how the hell that happened, but there's that. This is the actual MedRad device. This is not the computer that's over here that's running it, that you can still receive email on. This is the MedRad system. And I take it a lot of people in here know about medical devices. So if I mention the word an MRI quench, would anybody know what that is? Oh gosh, you don't want that day. You do not want that day.
Ask what's the cost.
Oh, gracious. So, okay, so the cost to get this off of this MRI, I don't even want to know, because I know it had to probably cost $30,000 or $40,000 just to have it maybe re-imaged, reset up, and have a specialist come in there
Now it belongs in North Korea.
and look at that. Yeah.
So,
The quench was probably hundreds of thousands.
Oh my gosh.
okay, so question here. So I imagine this MRI quench, did I use that word correctly?
You did use the word correctly, but this one did not quench.
Okay, so this machine here, I imagine the hospital bought it, the company shows up, they install it, they set it up to spec, they leave, the hospital operates it.
Yeah.
So if the company sets this up where it's vulnerable to WannaCry and the hospital gets hit, does the hospital have any recourse to say, hey, you guys fucked it up?
Well,
Or do
here's
they
the
have to-
thing. You have to ask that IT department, what IP addresses do you want in here? And if they give you the wrong IP addresses, you know, it's kind of like shit.
So it's actually
Yeah.
explicitly whitelisting.
Yeah,
Okay,
exactly.
that is stupid.
So I will explain what a quench is. It's when the MRI superconducting magnet suddenly loses its superconducting state. The magnet stops being superconducting, the magnet field collapses, liquid helium rapidly boils off into gas, pressure spikes inside the magnet, yes. The gas vents out through a quench pipe into the atmosphere. The magnet becomes completely unstable until it's recooled. A quench can be intentional or accidental, and it usually happens when there's a power failure. Now, I will say that I keep up with this stuff. So locally, we have had it happen a couple times. And there was one a couple of years ago at a children's hospital locally.
What kind of area does that affect? I mean, like,
You would have to evacuate.
evacuate
Yeah,
the entire
because there could be an explosion.
and explosion.
Yeah,
So if I live next door to the hospital, am I going to have to evacuate? Like, is this Chernobyl or?
it's not Chernobyl,
Okay.
but
Usually
it
it vents outside, but it can displace all the oxygen
Yeah.
Oh shit.
In the room?
What a shit way to go.
And then if
Feel like it sound like a mouse.
yeah, and then if
If you
there's
squeeze
blood,
like a
like all
exit
that
bag,
oxygen.
and basically all the liquid helium turns into gas
Oh,
immediately. And then everybody just drop dead.
yeah.
You don't drop dead, you can't breathe. Well, that's
Then
what I
you
mean,
like,
like,
you can't
sound
breathe,
like,
yeah.
and you'll be talking, you suck on the malaria.
Does that happen in someplace like
Pass
St.
out.
Jude's or something?
Yeah, I mean,
All right, so Dr. Olds was saying,
So if everybody starts talking like this, then you just gotta get the fuck out.
Yes, yes, that's right. If you're, and it may give a funny smell in there. So if you're near an MRI, and that's why they always say, they put all these warnings up around MRI systems. You know, don't enter this freaking room unless you talk with somebody, you know, up front. And that's something cybersecurity folks have to be made aware of as well. If we're in IT cybersecurity, we have to know where we can and we can't go. And, you know, talking about firewalls, we want firewalls on this MRI, but not on the MRI. We want it on the system that's before it. We're not going to go in that room ever. And it's because of that. We don't want to cause any type of issues or quenching, reboots. We don't want any of that. So yeah, that's probably the scariest thing I've ever seen in my life.
That children's hospital one you're talking about, wasn't that because somebody walked in there with some metal? And like, because I think I heard about that where it's like, that's why they don't allow metal in there, because if it does hits that machine, the only way to get that metal off the machine is by quenching.
Gosh.
Basically turning it off.
So that is another issue that you're talking of. I know the biomeds at the hospital where that happened, and they said, can you believe this? And I said, oh, my friends, I know. It does happen a lot where people will walk into these rooms and they'll have metal. Like, I know there was an instance where a police officer walked into the room and his gun was taken out of holster, and I believe it fired. I don't know if anyone was hurt, but that did happen.
And then they
With
gotta pay
Terminator,
$100,000 for that machine. You gotta turn it off to get the freaking gun off.
Yeah.
We could just leave it on and run it, right?
No, we don't want to do that. Yeah. You got to have experts flown in if there's nobody local. It's a very big to do. It's very expensive. Oopsie.
Not to mention that machine's down for patients too.
Yes. Yeah, that whole department's down. And the ER probably went on divert as well, because they're like, no, if somebody needs an MRI and they're coming in via ambulance, we can't accommodate them. So here's a couple more you may or may not have heard of. The Medtronic device was recalled because the wireless interface allowed unauthorized remote insulin delivery. And I think something like that was done at DEF CON a few years back. So yeah, that's where that one came from. The Johnson & Johnson pump was recalled because weak RF communications, the pump could be hijacked up to 25 feet away. So we know about this issue, and I often ask manufacturers when I meet with them at our BAMI meetings, hey, do you have RF turned on your equipment? And they're like, why do you ask? And I was like, well, you may want to turn that off. And finally, we have the Abbott pacemaker. It had a problem with firmware vulnerabilities, allowing for the potential manipulation of pacing. And that one had 465,000 device recalls. And here's something scary. Those devices may still be out there because in some cases when someone is having a pacemaker or a cochlear implant, any type of implant put in, at some point, if that device has to be switched out, that patient may not be eligible for surgery because of their age, a condition. So these devices are still out there, and hospitals need to be aware that, hey, we may have this type of device coming in, so we need to put this patient in a special room that may not have any type of wireless, any type of connection to it, because at home they don't have that because they know it could be dangerous.
Silence gonna need to start making jackets.
So this is one of my favorite systems. When I was doing my research, there was so much that came up about the volcano. So something interesting here, if you'll notice the dates. So this was initiated by the firm November 3rd, 2017. The recall status was terminated October 20th, 2023.
After DEF CON, which is not coincidental.
Yes, after DEF CON.
So this was big. Whenever me, Turtle, and Tremere were running around the biohacking village, they had a CTF going where you could beat up medical devices. There's an NDA involved, but this was one of the devices that were found in 2023.
Yep. So the manufacturer's reason for the recall, and this all comes from FDA. I don't make any of this up. I pull from FDA or one of the other governing bodies through other countries. On certain impacted systems, an unexpected Microsoft Windows security dialog may appear during use. And the user response to the dialog may adversely affect the subsequent operation of the device. So if you click that device where it says, hey, we're going to scan your system now, it reboots. The problem is they're inside the body. So this has happened several times with this system, and it took quite a while to get that issue kind of cleaned up. Yes?
What sort of a device is a volcano? What is
This device right here, the volcano.
is it a pacemaker or what
So this is an ultrasound system that will go inside.
okay, got it.
Yep.
How does the ultrasound system, like they give you a pill and you swallow it?
In many cases, this is a guide wire that will go up through the leg.
Oh, the femoral artery,
Mm-hmm.
or articular.
Yeah. Okay, so in 2019, Spring Hill Medical Center in Mobile, Alabama experienced a ransomware attack. Unlike many incidents where hospitals switch to downtime procedures and continue operations safely, this attack was different. It disrupted critical care systems across the hospital, including the network that supported fetal monitoring and the labor and delivery unit. During the ransomware event, electronic systems used to monitor fetal heart rate and maternal vital signs were offline. Nurses could not view centralized monitors, and they could not remotely observe signs of fetal distress. The attack caused delays, missing data, and gaps in communication that would normally help clinicians intervene quickly. Despite the outage, the hospital continued admitting and delivering patients. One patient who arrived during the ransomware outage labored without the benefit of the full monitoring system. The medical records show that the staff did not have access to the normal alerts that indicate the baby was in a crisis. The baby was delivered with the umbilical cord wrapped around its neck, something that monitoring would normally have detected. Tragically, the infant suffered brain damage due to the prolonged oxygen deprivation, and he did pass away 9 months later. This was one of the first cases, as you can read here, in U.S. history of someone actually passing away or losing their life because of ransomware. So what kind of hospitals are getting hit? Anybody?
Probably lower budget if I had to guess.
Yeah, regional hospitals.
They're all getting hit. They are all getting hit.
Sinus is huge. Boston Children's is huge too. So there's a really actually interesting thought here on that cost of life and where it came from. She's talking about that ransomware in Spring Hill. I'll give you two guesses as to what region that ransomware group operates out of. Close.
Korea.
North Korea.
Yep.
So there's usually like there's a honor among thieves, in this case ransomware groups.
They don't fuck with hospitals.
Yeah. Most don't.
No-cos do.
Middle East and NOCO do not care. They will hit
Yeah.
anything.
Romania will fuck with hospitals. North Korea will fuck with hospitals. Some Chinese will fuck with hospitals.
And that's actually who that was for Spring Hill. It was
Yeah.
a re-variant from NOCO.
They don't give a fuck.
Most of them, especially like groups that target the West, or groups that are like from Russia, like China, from the bigger organizations or bigger groups, they're trying to make money. They're not trying to cause impact. So you start taking lives, people really start paying attention, and the force is long as you don't affect life and limb, you're just ransoming people and they have to pay out or insurance has to pay out, how often are we cracking down on it? Not much, right? You might see one every 5 years get caught. So realistically, as long as they avoid that, they keep each other safe and in business. North Korea doesn't care.
Iran says they don't care either, but they fucking suck. So, but yeah, Iran, North Korea, and Romania, they don't care.
Anyway, sorry, random tangent.
You're good. You're good, man. I want everybody to speak. I love the engagement. So here is something interesting. These attacks are DDoS attacks, right? So for anybody who understands or uses the OCR report, the Office of Civil Rights reports, DDoS isn't on there. So this doesn't get reported. It's just kind of like it may or may not happen. And I have to say, I didn't know about any of these attacks until I was doing my research. And I put the sources of where I found each one of these. It certainly wasn't the Office of Civil Rights. So that data is not getting logged anywhere. But I will tell you something else that is interesting. Yes, another page. And there's, as you know, hundreds every year that could be on this list. Absolutely.
Did they get hit again?
So
Pittsburgh Medical Center?
if you see this, Cedars-Sinai got hit twice, 2022, 2023. There may be doubles on here where they were hit a couple of times. Hollywood Presbyterian. But what do you notice that's interesting here?
2022.
It's all killed it.
Yeah, it's all KillNet, which is
Yeah, we're good now.
So depending on the patient's, that date will be held for ransom. So if you have a celebrity in one of the celebrity hospitals out in LA or out in the Northeast somewhere, your date is going to be a lot more because TMZ wants to know if so-and-so is pregnant or if they just had a drug overdose, and they will pay for that information. They'll pay their financial services.
How much will they pay? Just out of curiosity.
It is.
How much?
Yeah, a lot. You're looking at $100,000 paycheck right there, depending on who it is.
Hey guys, Robert Downey Jr. is back in Rio. Oh, what? Yeah? Yeah, you just gotta take a look at her Instagram and you know. Leave Brittany alone, guys.
So these are the drug diversion studies that I've done. And it's clear that medication diversion, that misuse is an issue in healthcare wide. You have to think about the front of the hospital. I mean, those doors are open. It's not like when you go to your local Capital One, the doors are locked. You've got a badge to get in there. They're going to look at you funny when you come in, like, people on here. That's not so much in the hospital. I've seen sharp containers go missing. We don't know why they're going missing, but I can assume. I've found drug pumps that have been stolen and found on train tracks in certain areas because that's where people go to do the drugs. People claiming to be an unconscious patient's family member to steal their drug pump or whatever's in that pump. Patients not receiving full doses of morphine. Drug pumps with medication inside, left unattended in hallways, especially after hours. And I've seen employees of an organization found in their cars with needles in their arms. This is a big issue. Yes, please.
I've actually, the one hospital is actually keeping you in the ER area, and you actually have to get badged into getting out of that open door area. And that's new. Before, they just kind of like.
Yes.
I think the other, actually, Brooksville is doing that too. So yeah, they're trying to control that access a little bit.
I'll tell you what's really cool is I see physical security up there and they're checking bags as people are coming in because they're trying to keep weapons outside so that these weapons aren't used against our healthcare staff. But what they're not doing is checking the bags when people are leaving, because if you want to take a drug pump, you only need a backpack because you're just going to unscrew it off the pole, put it in your backpack and walk out with it. And if the patient's unconscious, no one's going to say anything.
If you walked up to a dope dealer with a drug pump, like, how much would you get with that? Like, here's this medical equipment, and the dope dealer's gonna be like, dude, I don't know what to do with this.
What's inside that?
Yeah.
We don't know, but it might be good.
I'll give you $10 a dope for this.
They can send it off to a third world country. We've seen that. Okay, so software firewalls. There's a lot of them. And while yes, it's a great thing that medical devices are now turning on those software firewalls, we have to keep in mind that that software firewall is not going to get an update. So it's not 0-day proof. It's going to only be updated to the time it was installed on that device. Yes.
So is it because they just don't work on updates, or they just like, well, we put it up, it got updated, that's it?
The manpower it takes to create that update for a medical device is a lot. You figure one medical device, and let's just say it's a surgical robot, and let's just say it's running Windows 10, a specific version of it. Every month it could have anywhere from 50 to 200 vulnerabilities on it that company has to go through and check and make sure is not going to affect this device. And if there is one, they've got to put a fix out for it. So it's more important to put the fix out than to do the update, because once you do that update, you're introducing more vulnerabilities, because there's always that bloatware that comes with updates. It's like, how did this come up here? Why is Discord now coming up? Because, well, there's a little bit of bloatware in the update that happened before this meeting, and now Discord is coming up again. Does that answer your question? Good.
Dude, I'd love to like to have an Xbox Connect going while you're doing an MRI or something.
So here's my professional opinion. The software firewall should be part of the defense in depth process. It absolutely should be turned on, because it is blocking some pretty notorious malware exploits and injections from yonder days, because we don't see those too much anymore. So we definitely want to have that as part of that defense in depth process for the medical device. Hardware firewalls. Who here knows about the story of Sophos? Oh, you're going to learn tonight. You're probably going to go to work and be like, do we have this firewall? Okay.
There were a bunch of Sophoses within the DoD, and people were pissing their pants.
Yeah. Yes. So China-based threat actors have been running a sustained 5-year campaign against Sophos firewalls. This wasn't a simple smash and grab ransomware event. It was long, strategic, intelligent operations. They began by breaching Cyberom, a Sophos subsidiary, to understand the internal architecture of the firewall. That allowed them to develop exploits tailored to those specific devices. The major turning point came in 2020. Whoops, sorry about that, guys. Am I on the right one? Yeah. It was the firewall. Major turning point came in 2020 when a zero-day vulnerability was used to compromise roughly 81,000 Sophos firewalls worldwide. Early on, the attacks infected everything they could, but over time, the strategy shifted, and they started targeting government agencies, critical infrastructure, telecommunication, and healthcare organizations. Sophos eventually discovered firmware-level persistence, including a rare boot kit designed to survive updates and reboots. The attackers also built fake Sophos update servers so the firewalls would reach out, trust them, and pull down malicious code. By late 2024, the US indicted a Chinese nationalist along with the company Sichuan Silence Information Technology, tying them directly to the operations. So, here's the saga. They found it, December 2018. It's still ongoing. So listing out the events, we can see the first breach was December 2018. And in October 2024, Sophos released Pacific Rim Report on a multi-year Chinese-based campaign. Here we are at the end of 2025, and it's still an ongoing issue. So if you have this wonderful firewall, I encourage you to be mindful.
It's ongoing because they're just not being patched, or it's still the hardware itself.
They're EOL technically.
Oh, Goler, okay.
Yeah.
Yep.
So not their new stuff can it's installed.
Well, nobody's using their new stuff because they acted so piss poor about their stuff.
They're all small and medium business. All Sophos stuff. That's pretty bad.
So why this is a problem? We're talking about unmanaged medical device firewalls because do you know how many firewalls are in your healthcare network? I never did. I was like, oh, look, there's another firewall. And the only way I really knew is I started tracking the MAC addresses of the firewalls in some of the programs that we had bought. I'm like, okay, I know this is part of the MAC address. Let's go in here to the Palo Alto and see if that's pinging, because if that's pinging, and we don't, let's say, use SonicWall firewalls, but we now have SonicWall firewalls, we know that they're covering medical devices. So that's how we discover a lot of these firewalls. So let's look at the problem of unmanaged firewalls for a moment. And by unmanaged, I mean what has been put in place and forgotten and unpatched. This image shows how an attacker could reach a medical device and ultimately the patient by exploiting gaps and firewall oversight. The red arrow pointing at the internet and the medical device shows an often seen issue. The medical device has been incorrectly configured. We've all experienced that. I've done it at home. Bypassing several layers of protection and direct facing the internet, as we saw earlier. From the internal threat perspective, the other red arrow indicates that IT could unknowingly use a tool like Nmap to identify open ports on the firewall, thereby bypassing it to scan the medical equipment which may be in use. And that has also happened. As we talked about earlier, and according to the FDA, this was the case for several of those GE volcanoes that we talked about. They were scanned and the devices caused the Windows security dialog box to start up. That's what happened. So we're going to take a look at some firewalls now. Let's talk about this bigger one here. That is a German engineered, and it came from Zeiss. Zeiss does microscopes for different types of surgeries. There's also a second one here. It's a little purple and white one. That's an Extreme Defender. So I beta tested those on one of my networks, and it worked out very well. It worked out very well. The only issue that I had, they got a little hot. And when these devices get a little hot, they could touch newborn skin. We don't know. It could. Or it could touch skin that doesn't have that elasticity that it once had. So it could be an issue having that device connected to a medical device to protect it. I don't know if anybody has seen the M guards. They are still out there. There's a couple of different versions of them. These are 100 megabit per second firewalls. So they don't work with imaging equipment that's sending at 1 gig, 10 gig. It's very specific device that those will work with. The cons of this device is that it hangs off the device and doesn't tolerate being crashed between a door and the medical device. So they often get injured because it is, if you look at it, the design is very wonky, and it is a USB to Ethernet connection that you're seeing there. So this was an interesting one that we had built and beta tested from Phoenix Systems. It's very clunky. It was very big, about as big as this table. And I was like, I don't know where I'm going to put that or what I'm going to put it on because it's so big. But it was, I applaud the engineers who designed it for testing purposes, because it's not something as an engineer I could do. So let's take a moment and look at non-encrypted versus encrypted. Deciding to turn on encryption in a hospital. It's a serious decision. Some hospitals can't do it because they don't have that bandwidth. It's expensive. It takes up a lot of bits. So if we look at how long it would take for a 20 gig image, so we're going to look over on packet size and GB, 20 gigs, are we going to send this through the network, encrypted or unencrypted, and at what speed? These are the times that you're going to experience roughly. And I have to say, I have seen whole logic systems send images that were 100 gigs And it went at 1 gig encrypted, and it took 20 minutes for it to get from one room to the other. Yes.
So, I don't think about, images in terms of gigabytes per se. I think of more megabytes or maybe terabytes. But I mean, like, what do you use? What kind of image do you send that's 10 gigabytes?
It depends. Pathology, some pathology images are hundreds of gigs, and it's because they're specific slices. They have to get down to the cellular level to make sure they've gotten all the cancer out of a patient or that anomaly that is within the body. So that's one.
Very extreme resolution.
MRIs, yes.
Yeah, MRIs. I mean, it's essentially a magnetic resonant 3D image of a thing, and that's going to be a lot of fucking data.
There's also this new thing on the market. It's called surgical theater. Well, I guess it's not new. It's been out for a while now. But they take images from CT, MRI, and several others, even x-rays, and they bring it together and they create one big image. And boy, yeah, it would take a little bit to get across there if you were going to encrypt it. So it's a choice. Do we encrypt? Do we turn that on? Do we turn it off? Yes.
So you're the subject matter expert as far as securing a lot of these medical devices go. I know in aerospace, a big blocker for us is the ability for retroactive systems to be able to communicate with the new stuff. Is that still because, like, being able to, like a legacy system not having the necessary certificates to communicate over HTTPS with something new, kind of puts the kibosh on a lot of these newer systems being able to communicate with that stuff. Is that the case in medical as well?
Yes, it is, because
there
those
has to be 100% like backwards compatibility.
sometimes those devices work together. And the example I can give there is a CT machine and a surgical robot. So sometimes we're using that surgical robot and we have to see images as we're doing this surgery live. We do have that issue. There's a process in place, and that process is, hey, that OR's got to go offline when that surgical robot and that CT machine come together, because let's say that CT machine is older than dirt, but it still works and it's still functioning, it's still doing what it's supposed to do, but from a security standpoint, it may be using TLS 1.1. And this new machine, if it's using, let's say, the latest and greatest version of TLS, and it also has 1.1 and the other deprecated versions, once that comes together, what happens? You can take that secured machine that you've spent all that money on and you can tank your security on it because you have to connect it to that other CT.
Yeah, now the device that's using 1.3, for instance, has a negotiated handshake with 1.1. So now they're both using an insecure protocol.
Yes,
But if
they're not using 1.3 at all.
do?
So it's like, and here's what you do. If you can disconnect it from the network as you're doing that surgery, that is the best thing to do. Or you can put a firewall in front of that surgery room, either at the command center, because some surgery rooms have command centers. You can put it back there and just have it run through that way and have it run encrypted. Yes.
You promised us some good news, so I guess I'll ask.
It's coming.
How long do you foresee these legacy systems being phased out to, we'll call it modern, for lack of a better word?
This is going to take probably 20 years.
For context in aerospace, the DoD and Boeing and Airbus are still ordering parts that Honeywell, or that my employer, whatever fucking Honeywell produces from the 1980s.
Yep.
Yeah,
Yep.
And they're ordering them like off the shelf.
A lot of it, these are like to build a hospital, these work just like manufacturing plants. Like when they build out a whole factory to say can, Pepsi, stuff like that, they're ordering that equipment and paying millions and millions, sometimes billions of dollars for that whole process. So they're financing that process over 30, 40, 50 years. So the plant has to last the life of it. They can't do upgrades in place because they're literally still paying off that piece of equipment.
Yep.
There's no hot swaps, there's no having a 2 is 1 rule or anything like that. Like the process is what's there, and that's what you get.
There's no upgrade, there's no, oh, we can just go buy a new one. No, you can't.
Yeah, and that's a very good point, just going and buying a new one, because the makes, the models, the builds, all of that changes, and all the parts that are inside that device, well, they've all changed as well. They're different models, so you're not going to get the same thing, and you may not get the parts that you need. So one thing, another issue that we see out there is parts availability. It's like, okay, well, we've spent $100,000 on this device, and there's no more parts available for it. So now we're forced to spend $1 million to replace that device. Is that in the budget? But yeah, that's a great question. Okay, hardware firewall issues. I know. This table was brought together to show all firewalls have issues. What this table tells us is that firewalls need management. They need updates. They need your attention. They may not need the services. They may not need deep packet inspection, but they do need to be able to have firmware updates. Most manufacturers are now electing to use something that is already on the market. That's your SonicWalls, your Junipers, your Ciscos. And while services are not used, again, that's like the sandboxing, we do need to have the ability to update that firmware, and sometimes there is a cost associated with that. So who takes on that cost? Is it going to be the manufacturer, or is it going to be the hospital? That's pretty much what you're going to get. Oh.
Sorry,
yeah.
we produced a big piece of shit. Do you have a support contract? No?
Yep. And you can see these issues started 2012, and we're down at 2025. They're still happening.
You better pay for our updates to the shit product that you bought.
So why this matters? Because hospital networks are now the most extraordinary and most vulnerable networks on Earth. And the equipment, in many cases, it's connected to a life. So this is a Carl Zeiss MedTech AG surgical microscope. And I believe this one does brain surgery, if I'm not correct here. But this is another one of my pictures. It's not very good, but you take what you can where you can. You'll see how it's kind of stuffed in that room. We've got room for it. We're going to protect it. We're putting it here. So these devices are specialized high-precision microscopes used during surgeries to provide surgeons with magnified high-resolution fields that are well lit in the operative field. If you're into photography like I am, there is a Zeiss lens that is out there, and I have to say, I have a camera, it's a Sony, and this camera is probably 12 years old, and it has a Zeiss lens on it. It is the most crisp picture. I can't buy anything on the market now that can compare to that Carl Zeiss lens. So when we're talking about a defense in depth strategy, healthcare environments vary widely in structure, maturity, and medical devices behave differently depending on the design, model, age, and use case. Manufacturers follow distinct development paths, support models, and risk postures. Security teams have different resources, priorities, constraints, and levels of education. A single approach will not fit every environment or device. And I say that because I see a lot of healthcare systems going out to these big conventions and they're saying, this is exactly what you need to do. Well, it may be working for them, but is that going to work in your environment? It may not. So what they're doing for medical device cybersecurity may not work at other places. And I've seen that several times. So my suggestion is that you stay flexible and consider alternatives. Okay, so we're going to get into my research. And the name of my paper, it's published through ProQuest. It's a quantitative study of firewall vulnerabilities and management and medical device security. So I'm not going to take you through the whole thing because gosh, that would be a mess. But I will say I did have a lab set up and I did attack a medical device, and I did darken out the comments that I use, the commands that I used here, because I thought it would be too much of a risk if that information got out. It would just be entirely too scary. So what I will talk about is what happened during all of this. So for this portion, I'd like to take a look at my Word document, if that's okay with you guys. Okay. Okay, so my appendix is huge. It's full. It's like 54 pages. We're going to start at T. My appendix is going to burst. Okay, so we're going to start off talking about SYN, SYNAC, and ACK. The TCP handshake, we all know about that. So these are the lab environment results. Port scan findings. Now using Nmap, open ports were identified on the medical device despite being segmented behind the SonicWall firewall. After resetting the firewall, open ports included 135, 139, 445, 5357, 5985. This indicated that the firewall did not filter or block reconnaissance traffic. The SMB client test allowed SMB traffic to pass through the firewall, but the device returned NT status access denied, demonstrating local access control was active. This revealed the firewall's ineffectiveness to filter SMB protocols. For my SYN flood test, the SYN flood executed with HPing3 reporting 100% packet loss, and no acknowledged were returned. The SonicWall LED lights indicated flashing in bursts, suggesting high traffic throughput. So, I mean, I was slamming that firewall with requests, and it was slamming so hard that it was just like, I don't know if I can survive this. I was able to get through it. And here are the results. So if you understand this, green is normal. Oh, I'm terribly sorry, team. I am terribly sorry.
Is there a way to share the work?
Let's see. Yes, there we go. I'm terribly sorry, team. I did not know. So let's put this here. And here we go. So here we see that the SonicWall had reported there's a possible SIM flood. Bigger? Beep, beep, beep. Maybe. Are you going to let me? Yeah, it's not letting me get up there. Oh, here we go. It's finally doing it. We'll just do this. Is that better? More? Okay. So it shows that on port XO, I was able to get through and get to, whoop. This one right here? Okay. How's that? Better? Let me move this out of the way. Okay. So this was a SYN flood attack that I did on the firewall. I brought down the firewall, essentially. I was able to get through it into the medical device that I had in testing. And that's what these yellow were being reported here. I didn't need a lot. I didn't need 30,000 bits of data. I just need a little bit to go through. And that's the result right there. Green is normal. Orange is a SYN flood attack. And that came directly from SonicWall. Yes. There's a cost associated with that fix. And I have to say, depending on the firewall that you want to use. There's a cost, and while you don't need services, you're going to need a lot of them, because you figure you're going to need, if you decide to go with a 10 gig firewall, you would need one per department, so one per imaging department, depending on the size of that department. And there's always the possibility that imaging equipment could be sending at 40 gigs pretty soon, so you may need a 40 gig firewall in there to help make sure that doesn't happen. Because I came in from the outside and hit that. That was not internal. So I did put together an asset tracking checklist for firewalls. It's a long read. I'm not going to make you go through it. It just tells you, hey, you know, decide if you're going to use 100 megabit per second, 1 gig, 10 gig, 40 gig. What type of firewall do you need? What type of data needs to go through that? And make sure you while you don't need the services, you do need support, because you need to be able to download updates for these devices. I think that's all I have on there. Oh no, there's this portion. So these are more screenshots. You guys ready for these? Okay, so I think we talked about this one. This was the Pyxis system. This is a telemedicine system that's located in India. It's giving us our vulnerabilities over here. This was a publicly accessible login screen. The user ID was available. I covered that up. I assume maybe we could do some password guessing to get into it. Login message screen from a healthcare delivery organization system. Another HDO. We had their internal mission, vision, values. We just need to click OK and log in. Warning, this is a medical device. That's definitely not what I want to see. Security warning. Okay, you're warning me, but you know, you've got a 2012 system there, and I know that I'm going to go out there and look and see what kind of vulnerabilities you've got so I can get into that. You definitely don't want that. Who knows what that is? Oh, well, it's telling us at the bottom. Blue screen of death on a Philips system. It was overwhelmed and it blue screened. This is a Siemens medical device that was found out there. 2002, and I think that 6002 port was open. This was a public RDP access detected on a medical device. And again, all of these, I scrubbed most of them so that they didn't have the HDO's information in there, because we're not going to do that. So this is an interesting one that I experienced myself. This was my terrible photo. This is malware detected alert on an ECAM imaging system. So it was an outbreak of worms on the ECAM system. And it took the entire ECAM system down. They all had to be rebuilt. And the cost to do that was $14,000 per device. And I think we had 10 devices. And this was a Windows XP system, so it was even worse. How many times have we seen this?
I mean, you gotta be able to remember, am I right?
Right? I know, I just write mine right out here on front.
I wrote it on my hand.
There's another instance, username and password, and this was in a lab. These were found in a lab.
We need to do more training, obviously.
So, Medtronic devices. This is another scary one. This is the diabetes system that we found out on Shodan. There's BD device. And that's it. So yeah, that's kind of what I have for you guys. What questions do you have? What comments do you have? Corey.
So, you said about the firewalls that you have to put in front of the medical device. Are you able to use all of the abilities of the firewall, like packet inspection? Like I know with like certain things like that I do for my clients, I can't have deep packet inspection affects the electrometrics
Yes.
their environment. So is that the same with these medical devices? You can't use like deep packet inspection and things like that on these firewalls?
You wouldn't need to. And it's because it's inside the hospital, and mainly what you're concerned with is a whitelist, creating that, okay, you're allowed to come in, you're allowed to come in, nobody else is allowed to come in here. So you don't really need those services. And I have to say, I haven't tested the services on those devices to see if that would have been an issue. But that's a good question.
Earlier, how you had the, I think the two systems, like one on 1.1, TLS 1.1,
Yes.
1.3, and then bringing them together for like an operation or surgery.
Mm-hmm.
What's the awareness on, like, who's coordinating that operation basically to move this device to the ear? Like, who's really? I'm assuming the doctors and things of that nature.
Absolutely.
Really.
And I have to tell you, sometimes when it's a very questionable situation, there should be cybersecurity people in the OR. I've been in the OR several times. I sit in the control room. I'm not up there, passing stuff around and helping out and let me sew that up. No, no, no. But you have to watch that equipment. Sometimes we have Wireshark running just to see, okay, there's nothing else that's coming near that equipment. It's a very real issue in some hospitals, because remember, we're all not on the same level. We're all not meeting that baseline yet. We're just not there yet. Some people are, but not everybody. Oh yes, so there is good news. So the good news is, thank you for reminding me that. So the good news is, once these devices are started and a case is going on, there are, let me bring this up real quick. Deet, 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 deet. I can't believe I forgot the good news. There it is. Oh, it's not going to show. I'll pull it over here so you can see it. So according to FDA ISO 62304, there's a locked operational state. So fear not if you're going to have surgery. Once that case is started, that device cannot, there's no changes that can be made to anything on that device at all. That includes your anesthesia machines, your surgical robots, any one of them. There is a stop mechanism that says no, that's it. It's on all medical equipment, even the old stuff. That's actually been around for a while. So they do. And here's the thing. If you have a medical device that is incapable of doing that, you got to get rid of it. You've got to get rid of that. That's one that's going to have to go to the pasture.
It's no less terrifying than having a procedure done.
But here's the thing. Hospitals are doing something. They know there's an issue, and they're like, okay, we've got to put all of this stuff in place. They're following NIST. The edge, they're doing everything they can. There's help out there.
It's back to like almost everything being designed and made. They're not putting security at the forefront of the design. They're just like, we'll worry about it later, and they never get around to everything.
It's hard to find talent that has an engineering degree that can talk about the device and cybersecurity and forward think, and be able to teach that information to a hospital to say, hey, when you bring this device on, you may not want to connect it to this type of C-arm, because when it's connected to this type of C-arm, you're going to have a cybersecurity issue. There's just not enough help out there, not yet. But they're aware of it. There's some very talented people who are coming together and just creating cybersecurity programs. Johnson & Johnson is one. They have a fantastic cybersecurity program, and they're sharing with other manufacturers.
The other problem you're running into here, dude, is it's also a political issue.
Yes.
So a lot of the standards and rules that like major hospitals or like like the conglomerate hospitals have to follow, it's state and federally mandated. So a lot of them, if they mandate something, they say thou shalt, the state also has to fund that project. So a lot of the times they're going to hold off on giving you mandates or telling you to fix a thing because now they have to pay you for you to fix the thing.
Yeah.
So a lot of the times there's no budget for security, especially in these kind of things, and in smaller states. So now they're just like,
No, I'm talking about the manufacturers aren't building, they're just building the device and not worried about
it's
if
like
they're adding security to a review
with
process.
these devices, it's just like for infrastructure. Security is last.
Yeah.
Availability and safety is all that matters. Outside of that, if they can secure it later, that's fine. Usually, with medical, they take security the same way ICS does. Hard outer shell, squishy center.
Yeah.
As long as you can put a perimeter around it.
Yes. In many cases, that is the case. As long as you can put something around it. You might not be able to touch that device itself. It's what you can do outside here to protect that device. And even it means, I have to take this off the network and I have to open up that USB port and move those files from here to here. That's what I've got to do. What other questions? Oh, the USB scare me. I'll tell you, we used to put those, we get the ones with the little hooks on the end and we put something like a lock on the end of it. So, if you're carrying that around, it's going to be uncomfortable. You've got to sign it out. That log has to be checked. We put it in a badged room. So if you badged on that and you're like, okay, I'm going to badge in just to get this. I badge out saying I took this. It's a heck of a situation, but it's what's working.
So just based off of the cybersecurity industry at large, usually whenever you call a hardware company that's providing cybersecurity solutions and you tell them that you found something naughty in their stuff, they get really pissed off. Is that your experience as well with medical companies?
Yes.
Yeah.
They don't like it. Nobody wants to see their name out here or being called and say, hey, listen, you've got a Pyxis med station that's open. I'm just letting you know. They don't want to hear that. Who are you? What's your name? Why are you doing this?
So
right, and it's like, no, I'm not hacking your stuff, I promise.
All I'm saying is if you create a burner Twitter and then post the vulnerability information
God.
in the New York Times or something, then magic shit happens, then you just delete the burner.
Yeah. But then there's the point that
if they know they're liable. If
Yeah.
they don't know,
Like, bitch, I'm gonna make you do the right thing. Yeah.
there's a lot of hospitals that,
You'll get sued.
I want to say that, and I'm going to stress this again, medical equipment is not IT equipment. It's just not IT equipment. It is something else. Yeah, it's the monster in the room. It's the elephant in the room. It's the scary thing in the room. If you're in healthcare, you have to have that person that you're going to call because these things are going to happen. You may not even know they're happening. You may have patients that are going into surgery and surgeries are getting canceled. And you're like, why are these surgeries getting canceled? Well, it's because the C-arm has been knacked. It can't send data from here to the screen over there, and they've had to cancel surgery. And it takes time to figure that stuff out. But I think hiring or having a subject matter expert with medical device experience and cybersecurity experience is the best way to go.
Boys, if you want your colonoscopy canceled, you know what you gotta do.
Yes.
So it sounds like
Those are PLCs in those devices too. So there's an OT issue. Yes.
It's kind of crazy to think of. We used to do operations without all this equipment, and people were dying in droves.
Mhm.
Now they're so scared of doing anything because they can't do it without the equipment because they're going to kill somebody because they
Yeah.
don't have the knowledge.
Yeah.
That's a scary thing to think about how much knowledge is being left
Yep.
behind.
That's what makes me think about the case with the hospital in Huntsville, where
Yes.
they were still delivering babies before they had that telemetry that helped them.
Yeah.
So I don't know the thought process that might have went into that, but it would seem like, okay, well, we didn't have this before, we should still keep doing, serving as a hospital for the community, but it is opening them up to liability and other people to risk. But what's the next closest hospital to Huntsville?
There's
Obviously,
that.
There's a lot less.
Yes.
So,
And what if this woman was high risk, you know, and the hospital, the next available hospital is not set up for high risk pregnancy, they're going to turn her away. You're going to have to go back there.
Now, with specialists, 30 minutes to the hospital.
yeah, so they might have a duty to stay open. Like,
SAMD, yeah, there's so many of them. Yeah, your cell phones are the software as a medical device. There's issues there too. Oh my goodness gracious. Oh yes. Yes. Absolutely. What other questions? What other comments? That's all I've got, guys. That's it.
One more question.
Yes.
So what's next for your research? Like what is next for you as far as like what you're putting together, your research?
So I have found that healthcare organizations and manufacturers are in need of someone like me, but they can't afford to have someone like me on staff. So I opened a consulting firm where I'm like, okay, all you have to do is call me and we'll worry about the logistics of payments and, you know, setup of fees later. If you've got an issue, you've got, let's say you're having an MRI quench and you're like, hey, Jen, what do I need to do? Because, you know, our biomeds are out or whatever that situation may be. I'm that person that you can call and I can tell you exactly what needs to happen, who we need to get on the line, and what type of emergency response plans you need to have in place for which devices, because they can be serious issues. What next am I doing? I'm publishing a book.
When's that supposed to come out?
It's almost finished, so probably I'm hoping June 2026.
Be on the lookout for book signing. Yeah, right. Do a book signing.
Yes,
Oh, shit.
absolutely.
I mean, if you're down, we totally said that.
Hey, I'm for it. I'm about supporting my people.
Okay. Well,
Yep.
give a big round of applause.
Thank you, everybody.
All right. Well, the mic's dead. I can't sign us off. So,
Programs that
okay.
it'd be easier to teach cybersecurity people about medical devices than it would be to teach medical.
It's time to say goodbye. Hello, it means goodbye.